Hello, everyone. So here's our second screencast for this week. The first one we talked about corresponding parts and how to identify corresponding parts of congruent figures, which is kind of the foundation of what we'll be doing. Now we're going to move on and focus mainly on triangles. And what we are going to be doing over the next couple weeks are learning about a handful of different triangle proofs that allow us to make statements of congruent triangles. The first thing I want you to realize is when we focus on triangles, because triangles have three sides and three angles, we have six corresponding parts. The three angles and the three sides make up six parts. Our triangle congruency statements really just allows us to use three of those six. So instead of using six parts, we're just going to focus on three. And we're going to have many different statements that allow us to, if these three parts are congruent, then the triangles are congruent. The first one we are going to look at deals with the sides of a triangle. This problem gives us information, but it gives us information in two ways. It gives us information in this congruency statement that BC is congruent to BF, CD is congruent to FD, but it also gives us the same information in the picture. They just mark it with the tally marks. The individual tally marks show that BC and BF are congruent, and then the two tally marks show that those two sides are congruent. So a couple different ways we can see or be given information about congruency is through a congruency statement or in a picture. What we want to do is justify or prove that those two triangles are congruent. And the statement we are going to use today is side, side, side. So notice we have gone from six congruent parts, corresponding congruent parts, and we're just going to focus on three. Something we have to know, and we're going to use a lot, is the reflexive property. The reflexive property is a shared side. So this side BD belongs to both triangles. So it's a side of this top triangle. It's also a side of this bottom triangle. A shared side is called the reflexive property. The reflexive property is given that it must be congruent because it's a shared side. So that is a term and something we'll use in all of our triangle proofs. So the side, side, side theorem basically says if the three corresponding sides are congruent, then that is proof that the two triangles are congruent, and that is our justification, side, side, side. We can see side BF corresponds to BC, they're congruent. CD corresponds to FD, they're congruent, and BD is congruent because of the reflexive property. That's enough information to say these two triangles are congruent because of the side, side, side theorem. Now, with that, we are going to look at a second theorem today. Get to the example, okay? And in this one, we're going to focus on not really this question right now. I want to just talk about what is SAS. So again, we're going to have a theorem that instead of using six parts of the triangle, three sides, three angles, we're just going to focus on three. The first one was side, side, side. Now we're going to focus on side, angle, side, SAS. This one is challenging because notice how this angle is between two sides. That is called an included angle. And I'm going to simplify a picture for that. If I draw a triangle, I have side A and side B. The included angle is the angle formed by A and B. The angle that is not formed by A and B, such as this one, is not an included angle. So notice side, angle, side. The angle has to be formed by the two sides. The angles that are not formed by the two sides, such as these two purple ones, are not included angles. So it's very easy to confuse this theorem because the angle must be included. If we look at this example, we have the reflexive property because it's a shared line. LB is a shared line. So again, that's the reflexive property. So we know that side's congruent. We're given angle L and angle B are congruent. So what other information would we have to do to prove that these two triangles are congruent by side, angle, side? Well, if we said that side LN and EB are congruent, that wouldn't be correct because, again, this angle has to be the included angle. So therefore, for side, angle, side to be a proof, we would have to know that NB is congruent to LE. And now we have side, angle, side. And we have that for both triangles. And that is a proof to say that the two triangles are congruent. And again, this all is just a way to use 3 corresponding parts instead of all 6. That is a start to our triangle congruencies. So right now we have 2 of them, side, 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 and side, angle, side. Next week, we'll talk about a few more, and we will continue to add to our list. So you should be keeping a running set of notes for triangle congruences that just keep adding all the different triangle proofs to it. And then the main idea is, can you justify congruent triangles by using one of those theorems? Hopefully that is helpful and allows you to get through your Math Excel practice this week. Please contact your teachers, set up meetings if you need help. Thank you.